Yeah, the first sample size formula that I'm going to share with you is known as Yamane sample size formula, which was introduced in 1967. Yamane sample size formula is we have the small letter n is equal to the capital letter N all over 1 plus capital letter N times e raised to the power of 2. E is the margin of error. The small letter n here, class, is the desired sample size, and the capital letter N is the population size. Of course, e is the margin of error, and 1 is constant, class. In utilizing this sample size formula, we have to consider this assumption, class. It should be remembered clearly that this equation assumes the confidence level of 95% and the proportion of zero point 0.5. Therefore, class, there is a complete ignorance about the behavior of the population. So let's take an example. Suppose there are 2,000 farmers in a certain locality, and you want to conduct a survey on their willingness to adopt the new farming technology. The margin of error is 5%. So therefore, class, just a matter of substituting the given values. So the population is 2,000, and the 1 is constant here, plus the population 2,000. The margin of error is 5%. So that's 0.05 raised to the power of 2. Then you have 2000 divided by u square 0.05. Then you multiply it by 2000, then plus 1. That equals 6. Yeah, then 2000 divided by 6, class. It's 333.33. Again, we will not apply the rules in rounding off in the computation of or in the determination of a minimum number of sample respondents. Automatically, regardless of the decimal value, class, round to the next full number. So it will be 334 sample respondents. Let's have another example. So in the event of a complete ignorance about the behavior of the population, this sample size formula may be applied, class, the main sample size formula. Again, the capital letter N is the population, small letter n is the sample size. Then we have 1 plus NE squared. E is the margin of error. So we have the population is 9,000, example, and the margin of error is 2%. So just substituting this to the formula, the answer is 1,957 sample respondents. And let's have another example. Determine the sample size the researcher wants to include in the study if the population size of her respondents is 475 with a given accuracy of 95%, class. Now, since 95% accuracy is to be evaluated, therefore, the corresponding percentage error is 5%, and that could be presented into a decimal form, which is 0.05. Now, applying the formula, we just simply again substitute the capital letter N, which is the population, is 475, divided by 1 plus the population multiplied by the margin of error, 0.05 raised to the power of 2. The answer is 217.14, and the final answer is 218, rounded to the next whole number, class. We have here the practice exercises. What should be the representative sample size if the population from which the sample will be taken is 10,000 and the desired margin of error is 2%. So again, substitute this one in the formula. Don't forget to transform the 2% to its in decimal form. So that will be 0.02. Then u square multiplied by 10,000 plus 1. Then 10,000 divided by the answer of the denominator, class. So the answer for this is 2,000 sample respondents. Exercise number 2, we have the researcher wants to know the average income of the families living in a barangay which has a total population of 2,500. We are going to calculate the sample size the researcher will need if a 5% margin of error is allotted. Again, it's just a matter of substituting this to the formula, class, the given values. Then the answer is 344.8, which is equal to 345 sample respondents. And you can also use the sample size calculator, class. You just copy this one and you paste it in the Google search engine, class. Then you'll be asked to type in the population and the margin of error. So just a click of your finger, automatically it will yield the answer for sample size.